Hello and welcome to Console Cowboys. Today we're going to take a look at wireless packet captures specifically for wireless penetration testing. So all the things that you need to do in order to figure out why your attacks aren't working, what data you need for your attacks, what types of attacks these networks are susceptible to. And we're going to do this all with packet captures, which is going to seriously upgrade your wireless penetration testing game. Because instead of just relying on automated tools and the output that may be right, may be wrong, may be missing, you're actually going to understand what's going on and how to figure things out. Now, I'm putting out this video because I've been on a lot of tests where people are looking over my shoulder or over at my laptop while they're doing something else, and they're like, why are you in the packet window all the time? And how did you find that weird thing in like this network? And it's all packet captures. So this is what kind of changes you from just a wireless pen tester into someone who actually understands wireless pen testing. So let's get started. Now you can follow along with this video completely by going to Wireless Pen Test Methodology Notes on my GitHub, which I will link below, and going to the capture section and just grabbing that packet capture. You can basically do everything we're doing. Or optionally, you could go to WiFiChallengeLab.com, perform your packet capture inside of that VM because you're going to download the VM and set it up, and then perform the analysis on that and perform the attacks that we find information on, as well as you can go through their PDF guide and do a lot more advanced things in there, which will be beneficial for you on the attack side. We're going to do the analysis side of things. Now, to get started, you go into the command section, which has all the attacks in here, but we're not actually going to do those. You're going to go into Wireshark filters, and this is where you're going to get your filters. You can copy paste, and we're going to break down what all of these mean, how to use them, how to correlate them with output of other tools. So let's get started. First thing that we're going to do is take a look at how to take that packet capture and then, what commands I used as well as what it looks like. So here's the packet capture I took. You'll see things like we have a WPA handshake up here. We're scanning on 3 channels at once, and we have all the networks over here on the right side that are available and that we see from our wireless cards, as well as information about them. And then down below, we have clients that are trying to connect to those networks or have connected to those networks. Now, if we look at my other screenshot here, this is the command that I use to take this packet capture. So if you're doing it inside of that VM, you can use this. I did sudo arrowdump ng -- band abg. The reason I did that was because the abg will get the 2.4 and the 5 gigahertz channels, which is mostly what we need to perform our testing. There is 6 gigahertz, but those are usually back channel between APs, and I haven't really seen them on a Wi-Fi pen test yet as an actual network to attack. So the next thing is -w capture test. That's just writing to a file we're going to name capture test, and we're going to use the pcap that comes out of that. Then we have WLAN 1, 2, and 3. These are the interfaces I am sniffing on. Usually I see people just sniff on one, but if you put a comma between them, you can sniff on multiple at once. That way, as it's rotating through the channels, you're sniffing on 3 channels at once, and you're less likely to miss things like WPA handshakes. So with all of that out of the way, let's load up that packet capture inside of Wireshark and take a look. So once you load up that packet capture, it's going to look like this, which is a ton of data that you have to go through. There's data, probe requests, etc., and it's quite overwhelming, but we're going to just break this down so it's very, very easy for us. Now, there's 3 types of frames inside of a wireless network. We have management frames, we have control frames, and we have data frames. Data frames we're seeing right here. This is the data going across the network. Now, we only care about that data if we're on an open network with no encryption and we can actually view the data, or we cracked a WPA or WEP key and we're able to plug that into Wireshark and then view all of the data clear text. Otherwise, we don't necessarily care what's going on inside that data usually. Next, we have control frames, which is stuff like quality of service, etc. You'd use that if you were analyzing a network, maybe doing a site survey, something like that, to figure out what's going on there. So what we care about is the last one there, which is the management frames. Management frames has our data from our machines to the APs things like authentication, disassociation, deauthentication, showing us all the capabilities of the router, what capabilities the stations support, etc. So you want all of that information, and you can figure out all your attacks from there. So how do we get that information? Because we don't care about this data. We don't care about this quality of service data. All we care about is things like our probe requests, which are management frames. So what would we do? We filter for management frames. So if we go back to our filters on the web page and we scroll down, you will see we have a frame subtype filter section. And I'm actually going to clean up this whole thing, but it's pretty good in this section. We have management frames, which are WLAN FC type equals 0. So it's the frame type 0. And if you were looking for control frames, frame type 1, data frames are frame type 2. So all you have to do is copy paste this in here, and we'll take a look at what happens. So if we paste this up into the filter dialog up here, hit enter. Now all of those data packets are gone. All we're seeing is probe requests, probe responses. We'll see some authentication data in here, stuff like that. These are the things that we want to see because we can get the data that we need. So once we have that, we've narrowed it down. There's still a lot of data in here, and we don't know where to start if we're not familiar with packets. So let's think about instead, what do we need to do on a penetration test to be successful generally in a lot of attacks? Well, the first thing that comes to mind to me is deauthentication attacks, right? If we want to capture a handshake or credentials on a management network or get web stuff, we want to kick everybody off the network and we want them to reassociate, reauthenticate. We want to capture those frames with that data in there with the authentication information and then perform our attack. But are we allowed to run a deauthentication attack on this network? That's the question, because there's something called protected management frames. And if this is enabled, then we can't perform those attacks because it's kind of like a CRC check in that it checks the validity of that packet or frame and makes sure that it's supposed to happen on the network. If not, it just drops it. So let's make sure that we can actually run an attack on some of these networks. We can do that by grabbing a different filters. So if we scroll up here near the top, we can say protected management frames. 0 equals false, meaning it's not enabled, which is good for us. 1 equals true, meaning that it is enabled, which is bad for us. Now we have WLAN RSN capabilities. We'll go through that inside the packet capture, what that means. And then MFPC for it's capable, C, or R required. And what we're going to do first is we're going to test, is this false on some of these networks? Meaning, can we run some attacks with deauthentication? So let's paste this in here. So we see here we do get results back. We got some probe responses, and I think I saw an EAPOL message up here, etc. So that means we can run some attacks on this network. So what networks actually are these? If I scroll this over so I get more room, I made this big so you guys can see what's going on, but it kills my space here. We see, okay, I can run deauthentication attacks on MyFibra, Wi-Fi One, Vodafone, Movistar. These are probably not in scope, but Wi-Fi Corp might be in scope. And looks like Wi-Fi IT might be in scope. So there is some stuff that might possibly be in scope. So we can take a look at one of these networks. I'm just going to select one here, and we're going to take a look at what this means. So we have WLAN, which is our wireless network, RSN capabilities. So how do we find that within this packet capture? So when you first open it up, it's just going to look like this. And we have our frame, then our probe response, then our wireless management section. So you can think of this kind of like your network diagrams if you ever took a networking class, where the top you have your application layer, the bottom you have your physical layer, in between you have like TCP, ICMP, etc., and it just goes down those layers. This is kind of like that, where we have our frame. Inside our frame, we have our probe request, and our probe request is a wireless management packet or frame. So we're going to drill down into that wireless management frame and want to take a look for RSN. So I'm going to close all of this stuff up so that way we can go through it as it would look for you. Okay, so when we open this up, we're going to see fixed parameters and tag parameters. We're going to look at our tag parameters. And inside of them, we're going to look for the RSN information because we have RSN up here. So we click that, and we're looking for capabilities. We want RSN capabilities. So what we're going to do is, here's our RSN capabilities. So we open that up, and we go down to management frame protection required. It says false, and it has a 0. It says management frame protection capable, false, and 0. So it doesn't even support it. So we know that this Wi-Fi Corp is susceptible to deauthentication attacks, and we should be able to kick users off the network if we're running an evil twin attack, or we're trying to get a WPA key, something like that. Now, what is Wi-Fi Corp? Well, we can look at our image here, and we'll see Wi-Fi Corp is a management network, meaning it's an enterprise network, so we're going to be getting usernames and passwords that we'll have to crack with something like a sleep or another tool. And it looks like we have two of those. One of them has 21 packets of data. The other one has 0. So this would likely be a better target right here, 2215. We can kind of see which one has more data going across, which means has users actually doing things. Okay, perfect. So now we know we can attack that, and we can look at all the ones that we can attack. But then which ones are actually protected? If we switch this to a 1, we'll see which ones here are capable. And I'm going to close this up here, and we're going to take a look. So we have Wi-Fi Global is protected in some way, Wi-Fi Regional in some way, and Wi-Fi Management. So let's take a look at Wi-Fi Management. If we look at this now, we'll go down into our RSA traffic. So here's our RSA. We have management frame protection. So this is capable of doing it, and it's protected. True. So we see a 1 over here, meaning that we can't run deauthentication attacks on this network. So therefore, we have to wait till things naturally occur on this network for people to naturally log on to this network to capture the four-way handshake if we were doing a WPA attack. So it's a little less opportunistic for us. This is how we narrow down what are the best targets on this network. Now, if we look at some others, we might see a different way that's set up. Let's look at Wi-Fi Regional here. And we'll scroll down, and we see management frame protection on this one is capable of doing it, but it's not required, meaning we could probably run this attack on this network with the deauthentication. So that's what that means, and how to figure out which ones are more ripe for us to attack using deauthentication attacks. Perfect. So now that that's out of the way, we can take a look at other things. So we saw a four-way handshake. So how do we take a look at that? So if we look at that, we have a handshake, and we have this BSSID. If we look at that BSSID, it's 2215. So 2215 is right here. We have some data on here. It's Wi-Fi Corp, and it's a management network. So it's a management network, enterprise network, so it's not a PSK pre-shared key that we can crack. So while this says we have a handshake, we probably can't do much with that inside the packet as far as a typical PSK crack. So what is that network, and what does it do? We can look at that in the packets. Handshake. All right, so we have check for four-way handshake. And we're saying WLAN BSSID, which would be that MAC address that we saw, and then end EAPOL. So let's just grab EAPOL. So we'll put that in there without the BSSID first and just see all of the EAPOL traffic. So we see, if we quickly look at this network, looks like we have some protected PEEP. So that's definitely vulnerable to attack usually, unless they're checking the signing certificates. We have some response identities, which likely have some potential usernames in them. We have our message 4 of 4, 3 of 4, 1, and 1 of 4, which is our four-way handshake. So that's likely the one that we saw there. We also see EAP TLS up here, which is not going to be probably available to attack. And we see some client certificates, which could give us good data to formulate attacks using similar data inside the certificates we use on, say, an evil twin attack. So this is all good data, but now let's get this down to, we'll say end-end, and we'll put that WLAN.BSSID. And what we're going to do is say that's equal to, you can use equals sign or equals. So now we're looking at the EAPOL traffic, EAP traffic of only that BSSID we got the four-way handshake for, which is that one right there. So we can figure out what this is. So this is a PEEP protected network, meaning that we probably can attack this. And then we see our four-way handshake and we see a certificate. Okay, so that lets us know that we can now formulate a evil twin attack against a PEEP protected network. I think we had our certificate. Let's take a look at the data in there. How do we look at that if we want to formulate a certificate for our attack that's similar? Well, there is a thing for that. So we have, all right, so we have extract certificates from a PCAP. So we can paste this in here and take a look at that, although it's a lot more messy to look at it that way. Instead, what we can do is we can use this T-Shark filter. And if we open up a command line, you'll see we can put in here T-Shark minus R and pull in our packet capture because we're going to replay that with R. We're going to grab the BSSID of the network that we want to attack. And we're going to say, give us the SSL handshake for that. And we click that, we get all the information in that. So we can see stuff like, what do we have in here? We have email addresses, pretty much all the normal stuff that you would see, name Madrid. So they're doing location of Madrid. So we take all of this data, and when we formulate our certificate, we make it look as legitimate as possible, close to what we see within here, and maybe it'll be accepted if someone's reading it and they're trying to validate it. So that's another thing that we can grab out of here. We can also look at the identities. So we said that there might be usernames and the identities associated with these networks. So we can say EAP, and if you look that up in here and say identity, you will see I have ways to do that. So we have T-Shark to do that, as well as there is a depreciated EIP.identity. It does work in the newest Kali, but it won't work in some of the other things like my Mac OS, but EAP still works, which is why we did that. So we did EAP, and we see all EAP traffic, which is also some of the identity stuff. So if we look at this in the packet, we scroll down, we don't see anything there, so we need the response. In the response, we see global anonymous. That might be a username. We see Contoso, so that might be a username we can use. And there are attacks where we can do live attacks on the network. If we know a username, we can directly just brute force that live. It's kind of noisy, but it is an option. So we can collect usernames for those types of attacks here like that. And then we can correlate that back to the other network. So if we went back to our old one here, so what was that? That was the EAPOL with the BSSID. So I'm going to do just our BSSID in here, and we're going to see what response entities came back with that. And we might be able to see if users are displaying those on the network or attacking, meaning that it's not properly configured. So we have our response here, and that is that Cortoso user. So we could technically brute force that on the network, or we can use an evil twin attack with PEEP. So there's two options for us now with that network, just looking at these packets and what's going on here, right? We correlate this data back with what we're seeing in here, and we get a good picture on how to attack it. So what else can we do? Well, we can also grab that identity directly. If you have something that supports it here, we can say EAP.identity, and then it will parse that out a little bit better for us. So we see just these two now, and that gets us the identity. But maybe if this was a big network and we had a whole bunch and we didn't want to go through all these packets and look at this, we can use T-Shark to do that. So let's use T-Shark to do that. So I have this up in here. So we can say T-Shark minus R, packet capture. We say EAP end-end EAP identity, which is our filter. And we'll say, give us EIP identity field. And it just comes back. Here's all the ones in the packet, which we saw already, global and Contoso. But now we don't have to dig into the packet to find those because we're using T-Shark to help us out a little bit there. So that's quite nice as well. Now, what other things could actually be useful for us? Are they using transitional networks that we can do a downgrade attack from WPA3 down to WPA2, and then we can run all our attacks like normal and make things a lot easier for our AP attacks or our direct PSK attacks. So let's grab that. We could take a look here. We look up transition, and we see this right here, and I can explain exactly what this is doing. So we have WLAN FC type subtype 8. Now that's going to be a beacon frame. You can find that out by going down here. So we have beacon WLAN FC type subtype equals 8. But if we didn't know that, right, because you didn't have my list of stuff that I'm giving you here, you could just Google that. Like, what is, and we're going to type this in, it'll tell us. Okay, so this is a Wireshark filter, and it displays a beacon frame, and then it tells you all about beacon frames and what they are, right? Shows you SSID, supported data rates, channel information, etc. So now we know what that is. We can take a look up here, and we have the FC type 8, so beacon frame, and then we have WLAN RSN, so that RSN field again, aka AKMS, which stands for Authentication Key Management. So this is just the hex value for WPA2 and WPA3, and we're going to make sure that this network supports both in the same broadcast request, meaning that we can authenticate with either one, meaning that it's a transitional network because it would only support one if it was WPA3 only. So let's do that. So we're going to pop that in there. And all we see is this one. It's for Wi-Fi IT. And if we look at what Wi-Fi IT is, we have Wi-Fi IT. It's an SAE network, so it's probably an open network, but it uses encryption with WPA3. So not as useful for us. It's just kind of a guest network. But we could take a look in here in the packet to see what we were talking about. So if we scroll down here again, I'm going to go to kill all these guys. So we can scroll back in again. So we want to look at the RSN information again, because we were using RSN. And we want to scroll down. And we'll see in here AKM, right? We see a count of 2. So we're supporting 2 different AKM authentication suites. And if we put this down, we'll see the 2 that we support. So we support PSK and we support SAE. So that'd be WPA2 and the WPA3 networks, meaning it's a transitional network. So you can start seeing how this is not that hard. If you know the filters to use, you can start getting a lot of information that you may or may not see in your tools. However, I will say you can see the transitional networks displayed as a transitional network. If you're looking at the Kismet output, it does list those things for you, which is quite nice. Now, next up, what if we just want to look at like data packets and see if we can get passwords and other things that are going on? We can look for open networks. So let's do that. So we'll type in open network. And we see right here is an FC type of 00, and that is our management frames. We're going to use a subtype of 8, which is our beacon packets we found out. And then we have WLAN fixed capabilities privacy equals 0, meaning there's no privacy, so there's no encryption. So we're going to copy that and paste that into Wireshark, and we should see what's in there. All right, so here we have 000 SID, which is probably a thing that is a cloaked SSID that we didn't see a probe request response for. And we have a Wi-Fi guest. So if we look back here again, we'll see, okay, Wi-Fi guest, where is that at in here? Here it is. So this Wi-Fi guest is an open network, meaning no encryption. It does have data on it, has 80 packets. So we could take a look at that data and see if that data has anything sensitive in there. It may or may not, but that's something that you could do during your test. Also, if they're running stuff over HTTP, then maybe you can leverage stuff with EtherCap or something like that with man-in-the-middle attacks and be able to intercept that traffic. Maybe somebody's on that network going to an HR site, something like that. And you could just get that data, get a username and password, which might be the same as their network password, which then might log you into the corporate. Who knows? But you got to tie those things together. Now we see down here this length of 9. That is probably our hidden one because it's also an open network, but there's no data on that network, so it's probably not that useful to us because we're not going to be able to see any data. But if we could do an SSID attack on this where we're just going to brute force SSIDs and be able to uncloak that if we guess the right one. So that's something that might be useful to us. We can also check things like PMKID, which is an attack that you can grab authentication key that you need to crack on a cached on a router, even if there's not a client on some WPA networks. So does that even exist in our network? It might. We can look for those sorts of things. So we can say WPA PMKID and just see if it's available on that network. If it is, it might be valuable to try that sort of attack depending on the parameters there. So we have that. And it looks like we do have this EAPOL here. And let's see if we can get any information on that. EAPOL RSN. Authentication. Looking for the SSID in here. It's hidden here somewhere. Open this up. I'm going to change my profile to something that gives me more information. So now I'll show you this later, but we can go to the source address, transmitter address. So now we can look up those BSSIDs. So we have 2217 and 5351. So let's correlate that back. So 2217, here it is right here. So this is going to be Wi-Fi Global. It's also another management network running WPA2, and it has quite a lot of data on there compared to the other one, 682. So now we know this is a management network, and it might have a PMKID. However, I believe the PMKID only works against the pre-shared key, so this wouldn't be a valid attack in that case. So then next up, what else could we look up? We could try to find out if this using Wi-Fi protected access, WPS, so we can run those attacks. I don't really see that often, but it could be out there. So here we would see this WLAN WFA IE type 004. We'll see what we might possibly be able to run an attack on that. So we have Wi-Fi Corp in here. So let's scroll into here. And if we scroll down, we also see SSID Wi-Fi Corp Legacy, which might be why this has that in there, because it's something legacy that's supporting this. Let me scroll this up, get this all out of the way. And kill these all off. I don't know why, but sometimes it just kind of opens all of these things. Also, another thing to think about too is this says like HE capabilities. Stuff like AC, HE, all these things just tell you what type of, like, how new the protocol is. So if you looked up HE for Wi-Fi, you get an idea of like how old that protocol is and then what types of data supports within it. So just a side there. But anyway, if you go down here, you'll see WPS is right here, Microsoft Corp. And if we open this up and we look down here, we'll see WPS 004 or 04. So now we have all of those networks that may support WPS. So Wi-Fi Corp, JSON, probably not in scope. Wi-Fi offices might be in scope, so we might be able to run that type of attack on there. Let me go back to our regular view. So how about looking for deauthentication frames? Let's say our deauthentication is failing. We want to take a look at, are they being dropped, something like that. Or is there an attack going on this network, like loads and loads of those? I don't know. So let's just look for deauth. So find deauthentication frames. So we're going to look for type 0, which would be management frames. And then we're going to look for this subtype right here, which is the subtype 0XC. And I think I have another way to do that in here as well, which is a little different. Because one thing you'll notice with Wireshark is you'll see many different ways to do things right here. Like, so this is disassociation and deauthentication. And that's not using a hex here. It's just using this WLAN FC type 0 again for management, but then it's using 12 and 10. So deauthentication and disassociation. So let's grab that and pop it in here. And that's going to give us an idea of what's going on in the network for that. So if you're running like an IDS, you might be looking for, tons and tons of these deauth really quickly, which might show that there's an attack going on. You see some deauth right here. So that would tell us something's going on in this network. However, because there's only 2 of them, it's probably just the AP deauthentication a client, not an actual attack going on. It's another thing to look at. Now, we've looked at a whole bunch of stuff in here. This would be the primary stuff we're going to look at when we're running a penetration test to correlate data for attacks. There's definitely other things to look at within different protocols, WPA3, WPA2, but that's the main things. The next thing to look at is how do we make some of this data look a little prettier so we can kind of quickly reference it. There's a manual way, and then there is a pre-done way for you. So the manual way would be, let's go into the coloring rules. And I have some set up here already. So I can just say add, and you'll see right here we have our FC type 2, which is our data frames added in here. But we're going to put, say, FC type 1, and that would be our control frames, and we'll just put control. And we can go down here and we say the foreground, whatever color we want. We could say we want the foreground to be, this would be the text. We want the text to be black. And we'll hit OK. We want the background to be, I don't know, brown. And we'll hit select. And then we have this data and the management frames I already did, which is green for data with the blue background. Management frames is yellow. And if we hit OK now, you'll see that as we scroll through, if we're looking at all these, we can quickly look, okay, here's our management frames, here's our data frames because of the colors. And there's another way to do this as well. So we can disable this really quickly by just going to coloring rules and just uncheck the ones that we don't want. So uncheck that, go back to our normal way. There's another way to do it too. So there's pre-done stuff. So I downloaded one, and you just go down to this profile and you left click on there, and now it pre-does it for you. We were looking at that earlier. We have some colors. We have some different formatting in here, and if this is useful for you, you can use that. And also that other thing I looked at where we could start looking at, okay, where's the subtype? This is a deauth packet. Okay, here's our receiver address, transmitter address, BSSID, if we need the BSSID to correlate back to our other data, stuff like that. And then if we wanted to load our own in, we can Google online for Wireshark wireless profile. If we right click on here, we can just hit import from zip file and just import that whole zip file. And then it will come up in this other menu when we left click. And now we can have pre-done stuff that makes it easier for you when you're analyzing packets, which does help in the wireless as well, depending what you're doing. You can do very specific rules, like you could say put an identity filter in here as like red, so you can see all the usernames, stuff like that. 4-way handshakes, you could color a specific color if you wanted. There is a wireless tab up here as well, and we hit the WLAN traffic. Now I don't find this all that useful, but it could be useful for stuff like, okay, data packets. Let's sort by the network with the most data packets. We have 8937. What is that? Wi-Fi old. Well, Wi-Fi old says that might be using bad things that are vulnerable, and it has a lot of traffic on it. So let's correlate that back. So we have Wi-Fi old. Ooh, yeah, that is a WEP network, and it has a ton of packets. So we could easily crack that. Now it's using WEP. So it's likely something that doesn't support new hardware. So it's probably something like medical equipment if you're in a hospital, which might have sensitive data, PII on there, and you can definitely crack those. However, I would suggest you ask the client's permission first and ask them what it is, because you don't want to take down industrial control system or medical equipment that might actually be needed. So you might want to then get the WEP key from the client and see what clear text data is running across there and not actually crack it, because we know we can crack it. It's WEP, right? So just things to think about. We also have like the next up is 691 packets is Wi-Fi global. And we have Wi-Fi guest has 80. So we can kind of figure out which are the best targets for us to attack that have the most data and things going on them based on where we're sitting right now. So that's going to conclude this video. Hopefully you learned something. If you did, definitely like and subscribe. If you found this useful, definitely let me know down in the comment section. We covered a lot of wireless stuff. If there's anything specific you're looking for, maybe I can do another video. But I think this covers the majority of stuff that you would really need for running filters and correlating attacks for wireless networks. So thanks for watching, and I will catch you later.